Today we are going to review Module 7 right triangles. So first of all, what is a right triangle? A right triangle is a triangle that has a right angle. Now, with this right triangle, the first thing we moved into was Pythagorean theorem. So we're going to move right on in. So with Pythagorean theorem, you have legs which sit around my right angle. There's my right angle. And then across from the right angle is what we call a hypotenuse. Now, with our right triangle and with our Pythagorean theorem, the legs do not matter who you call A and B, but your hypotenuse is always C. So C squared equals A squared plus B squared in our Pythagorean theorem. So the first part of the unit, you were just finding a missing piece. What does that mean? So that means I was given a right triangle, excuse me. Let's just say that he was 5, and let's go ahead and look for a leg. We'll make him 7. So we said, okay, you just identified he was A, he is B, and he is C. So I had 7 squared equals 5 squared plus B squared, because I'm looking for B. So now 49 equals 25 plus B squared. I have to subtract the 25 from both sides. So then 49 minus 25 is 24 equals B squared. And to get rid of the square, I take a square root on both sides. So B equals the square root of 24, which if they ask you then to give me an approximation, it is 4.9 is approximately B. That's just taking the square root on my calculator. That was the first part of what we did. We talked about the Pythagorean theorem. Now with that, they asked you if a triangle was right, acute, or obtuse. Real easy. If the Pythagorean theorem holds true, so C squared equals A squared plus B squared, then it was a right triangle. All you had to do was plug in and say, okay, let's just give you a 3, 4, 5 triangle. So biggest number is always my C. I just plug in. So then 25 equaled 9 plus 16. So because the two sides are equal, he's a right triangle. Easy, easy. So then we said, okay, well, what about if it doesn't equal? Then we can have what we call an obtuse triangle. Let's just say our C squared is larger. So if C squared is larger, just like an obtuse triangle is larger than a right triangle, or obtuse angle is larger than a right angle, then it's obtuse. So when I do the math, and I'm just going to make up numbers, he might be 27, and when I do the math, he might be 23. So 27 was larger, so that would make him obtuse. Then just like our acute angle, if C squared is less than A squared plus B squared, then it's acute. It's an acute triangle. Another example is if I had 27 is less than 30. It would be acute when I did the math. Then we moved into the harder part of our unit. The harder part of our unit was starting with our special right triangles. They are tricky. You have to memorize them. So, the first one we talked about with our special right triangles was we had a 30, 60, 90 triangle. What that means is I have this right triangle. He's 30 degrees, he's 60 degrees, and of course he's 90. It's all the degrees. Now with this special right triangle, there's a pattern. It says, okay, and what I always say to my students is, he's the small guy, he is the driver, he is my X, he is my one who's going to go. My medium leg over here is going to be X square roots of 3. That means whatever he is, he's the square root of 3 of him. That goes that way. My hypotenuse is 2 times that short leg. So we have the short leg, which I just called X this time, but he's called the short leg, whatever he is. Then my medium leg which is down here at the bottom, is whatever he is, square roots of 3. And then my hypotenuse is 2 times whatever he is. It's a pattern. So if this is 5, then I can quickly say, alrighty, this side over here is whatever the short leg was, square root of 3. He is 2 times the square root of 3, so he's 10. Just a pattern. All right, so if this side is 12, all right, we know he equals 2 times whatever that is. So what's the whatever? It's going to be 6, right? So he's going to be 6 because 2 times 6 gave me 12, so he's 6, and he's whatever that short side is, square roots of 3. Let's do one more crazy one. All right, I think this is the hardest one there is. When I'm given this side here as a whole number, how am I going to pull out what he is over here? Well, you know that he equals whatever that is side is square root of 3, right? So then I can just get rid of my square root of 3. So 8 over square root of 3 equals x, and x is what my short side is. But I can't leave the square root of 3 in my denominator. So then we call something called rationalizing the denominator. So I multiply both by the square root of 3. So he's 8 square roots of 3. Square root of 3 times square root of 3 is 3. Bam. Done. He is what this side is over here. Now, when I come to this, he's 2 times that. Well, when I multiply numbers, numbers multiply with numbers, square roots multiply with square roots. So 8 times 2 is 16, and leave the bottom. The good news is sometimes you can come up with this answer here in orange, and then get a decimal, and then check all your answers to see who matches that decimal. That's a trick you can do as well. The next special right triangle is what we call the 45, 45, 90. That means he's 45, and here's my 90. And if you remember with the 45, 45, 90, my two legs are the same, and my hypotenuse is whatever that is, square roots of 2. Because two sides match, it's the square root of 2. So, looking at my first little example here. So, if I gave you this to be 3, then he matches, he's the square root of 2. Here I don't have to put 45 in both because I could do the math and it's going to be 45, so it's okay. So let's just say here that I made this 2 square roots of 3. Well, I know automatically the other side matches, but my hypotenuse is the side square root of 2. So how do I simplify that? Radicals just multiply together, so it's 2 square roots of 6. So radicals just multiply together. So this would be the final answer for that side. And the last one, if I just put 2 marks like that, it means that my sides are congruent. And we know from Unit 5 if the sides are congruent, then the angles have to be congruent. Let's just make him 8 this time. All right, again, weird, weird, weird. He doesn't have the square root of 2 out of him. But we know he equals the side square roots of 2. And then I can just divide both by the square root of 2. So 8 over the square root of 2 equals x. Now, because I'm a really good math student, I can either A, play with the numbers, or B, multiply by the square root of 2. So 8 square roots of 2 over 2 equals x. 8 divided by 2 is 4 square roots of 2. So, wait, squeeze that in the bottom there, sorry. So, that means that this side is 4 square roots of 2, and this side is 4 square roots of 2. Which if I came back here and checked it, it'd be 4 square roots of 2 times the square root of 2, which would be 4 times 2, which is 8. That's the hardest it gets. So if that's the one that trips you up, then use this right here and find the equivalent decimal. That's the hardest one you got. Then we moved into trig. Now, the nice thing about trig is if you know trig, then you could do the special right triangles without having to know the pattern. That's the good thing about trig. So with the trig, we learned this little acronym, SOHCAHTOA. Okay, with SOHCAHTOA, it just sets us up to be able to find a missing side of a right triangle. So with SOHCAHTOA, all you're doing is I'm given a right triangle, I'm given a measurement. Now, with this right here, I'm given one side, and I want to find the other. All right, I can't use Pythagorean theorem, I don't have enough information. So what I can do is say, all right, from this angle right here, what am I given? I'm given the side that is opposite, and I'm given the hypotenuse because these are right across there. So who uses an opposite side and a hypotenuse? Excellent, sine. So the sine of the angle equals the opposite over my hypotenuse. And now we just need to solve the math, which if you remember is you can create this almost like a little proportion. I don't normally teach it that way. I just kind of do the math. But if you're kind of confused on how to do things, you can cross multiply here. If I cross multiply, I have x sine 37 equals 5. I have to get rid of sine 37 is a decimal. So he's got to stay together, okay? He's just a weird decimal. So now I just divide. 5 divided by sine 37. What I tell my kids a lot too is these two can just change places. So it's just 5 divided by sine 37. If x is on the top, then the two numbers multiply. If x is on the bottom, then you can divide. But whichever way works best with you. Now, here's the big deal. Ching, 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 ching. Calculator must be in degrees. All right, so 3 different calculators we're possibly using. So if you're using a graphing calculator, you hit the mode button, you scroll down and make sure degree is highlighted. Otherwise, every problem is going to be wrong. Okay, so you just hit the mode button, and then you look down, you see degree, you're great. If you're using Desmos, and this is the difference in the two Desmos. Oops, I forgot the last, Desmos. If you're using Desmos, if you're using just the regular Desmos Green app for graphing calculator, you have to change it. So that means if I go into Desmos, let me get in my little calculator here so you can see it. In Desmos, right here, because that's what most of you will be using, in regular old Desmos, you have to change it to degrees. So I have to hit this little coggy thing at the top, and you'll see at the bottom it needs to be put into degrees. That's important. That's important. You need to do that. Okay? That's important. Now everything I do from that on will be in degrees. That's when it's just in the regular old green app. That's the green shield. You have to hit, what is it, a wrench in the upper right to change. All right, but if you're in the Desmos testing, which is my blue app, you're good. The testing app automatically has you set to degrees, and I'll just show you that right away so you don't think I'm a liar. So if I come in here, I got my Desmos. This is the testing. I want to use the sign. Oh, I want to use the graphing calculator. Start my test. Yes, it's going to shut down my phone. That's just fine. It'll be fine. All right. But when you come in here, when I hit the wrench, it's already in degrees. When you're testing for your SOL test, it's the same one as that testing app, and it's already in degrees. So those two things. And just in case you were unsure with the graphing, I'll just come back right here. It's just the mode right here is the mode. Let's gotta turn it on first. That'd be good. You have the mode, and then you're looking down here to make sure it's in degrees. Okay? All right. Let's look at one more of those, because then it's just application of those. So I have a thing here. I'm going to make him just 52 degrees. I'm going to have him as 5 and him as X over here. So from my 52, this is my opposite. This is my adjacent. So who uses opposite and adjacent? My TOA. Oh, you can't see it at the top. It's my TOA. Opposite over adjacent. So the tangent of 52 equals the opposite over the adjacent. Now, because he's in the denominator, I just multiply these two. So 5, because I multiply both sides by 5, 5 tangent 52 equals X. And then we just solve it, whatever 5 tangent 52 is. Just multiply it. Remember, tangent 52 is one whole thing, so it's just 5 times tangent 52. The last thing, part of this section as well, you're talking about the inverse tangent. All the inverse tangent is you're trying to find an angle. Regular old SOHCAHTOA is trying to find a side. Inverse trig, or inverse SOHCAHTOA, you're finding an angle. So if I have this, again right here, I might have this being 3 and this being 4. What is this angle here? So I can say, all right, this angle here, well, what am I given? I'm given, again, an opposite and an adjacent, so it's a TOA. So the tangent of whatever this is equals my opposite over my adjacent. But because I don't know the question mark, he's just my angle, the question mark equals the inverse tangent, which is that second button, 3 over 4. And just put it in the calculator all at one time. I would just say, okay, tangent -1, parenthesis 3 over 4 equals to get my degree of my angle. And that gives me my degree of my angle. Now, the only other thing you'll see pop up, so I'm just going to go over it quickly, is an angle of depression or an angle of elevation. No matter which one is given, if I'm sitting down here like this, and I'm down here and I'm spotting something way up here in the sky like a bird, that's angle of elevation because it means my eyesight came straight up and straight out and I looked straight up. That's angle of elevation. It's this angle right here. It's how much did my eyes go up. If I'm looking right here, say I'm in a lighthouse or on top of a mountain, and I see this bug on the ground. Well, this is where it gets a little weird because your eyesight goes straight out, which makes this parallel to this, and I'm looking down at this bug here. But this is the angle of depression is what they call it. But because we know that these two lines are parallel, that becomes a transversal. It's still the same angle we had before. So if you're ever in doubt which angle you're looking at, it's always right there at the bottom. It's always the one that's right there. Because even if it's depression, it's going to be right here because of alternate interior angles. If it's elevation, it's right here because you're looking up for the ground. So it's the same angle on the inside. It just depends on what the situation is where you're looking at it. You all have an awesome day. If you have any questions, please contact me either by email or by message before your test, and we can go over a few other things. Y'all have a great day. Thank you.